Well, hello. Welcome to our decimal operations test review. Let's go to work. You try to stay ahead of me though, okay? So check your work. And if you pause it and just work ahead, you can zoom forward, backwards, just to get everything situated. So here's a couple problems. You can pause it, write them down, start working on them. And then fast forward me and stuff. If you got it right and you're good, then don't stick around. Let's move ahead. Let's find your misconceptions or the things you want to work on. Okay, enough of the intro, Mr. Weber. Let's get into the math. Okay, so the thing with adding decimals, we need to make sure we line up the decimals so we get our place values situated. And then we can just go ahead and add. 8 plus 7, when you're adding, you just have to be careful of the carryover. And when I say adding, okay, so we're just going down, okay? Just sliding right down, getting our place value situated. So 9 plus 3 plus 1, carry the 1. 6 plus 5 plus 1, carry the 1. 2 plus 1 plus 1, all right? And then I just need to make sure I line up my decimal and just drop it right into place. My answer is 4235. Let's do another one. Okay, this guy right here. And when you're adding, it really doesn't matter which one is on top. It matters for subtraction, and it matters for division also. Order matters in those two, but adding and multiplying, it doesn't matter. So everything's lined up. Let's go to work. 6 plus 2 is 8. 8 plus 5, 3, carry the 1. 0 plus 1 plus 1 is 2. 6 and 3 is 9. Line up those decimals so I can put my decimal right into place. Oh man, we're doing this. We are doing this. All right, this guy right here. I'm going to put the 15 on top just because it has more digits in it, but it really doesn't matter. I'm going to pop in a 0 here for a place value, and I'm writing really fast, so my penmanship is getting a little wonky. Sorry about that. I got a 2, 9 plus 5. I got the 4, carry the 1, the 2. Decimal slides right into place. 24.276. All right. If those were kind of bumpy for you, go back and take a look and see what's happening. Students tend to just not line up the decimals and they miss the carrying. So line them up. All right, for subtraction, the order does matter. What you have at the beginning is what you have, and that has to go on the top. So order does matter. So that has to go on the top of the problem. And when I'm subtracting, I do need to line up the decimals. So I'm going to get some zeros in here as place values. And when I'm subtracting decimals, I have to be careful of the borrowing. So right now, 0 minus 6 is not enough, so I have to borrow. I have to borrow all the way over here from the 1. The 1 becomes a 0, and I carry 1 over. So that's a 10. Now I'm going to borrow from the 10. So the 10 becomes a 9, and the 0 over here becomes a 10. I'm just kind of basically turning in dollars for dimes, turning in dimes into pennies, kind of just converting it so that I can use it. Now I can subtract. 10 minus 6 is 4, 9 minus 7 is 2, 0 minus 0 is 0, 3 minus 2 is 1. Drop the decimal into place. 1.024. Woohoo! All right, this next one, 5.2. It's what's on top, so it's what's first, so it must be put on top. Get my placeholder. Now I'm going to go to work. Got to borrow. The 2 is going to become a 1. The 0 becomes a 10. Some students often make that into a 9 or something like that. I'm not sure why, but just slide it over. We're not borrowing from that one. So 10 minus 6 is 4. Now 1 minus 8. Okay, we're going to have to borrow. So I'm going to borrow from the 5, make it a 4, and I'm going to bring 10 over, which that 1 becomes an 11. So now 11 minus 8 is 3. 4 minus 1 is 3. Decimal just drops right into place. 3.34. This guy here, 8.13 minus 2.716. Now I'm keeping track of lining everything up so I can make sure I'm doing the right stuff. So I'm borrowing from the correct thing. 3 becomes a 2, 0 becomes a 10. 10 minus 6 is 4, 2 minus 1 is 1. Oh, 1 minus 7, have to borrow. Don't be afraid of borrowing. 11 minus 7 is 4, 7 minus 2 is 5. I'm going to drop that decimal down. Nice. Here we go. Ooh, on to multiplying. Woohoo! Now multiplying, what I'm going to do is I'm actually going to ignore the decimal and do 72 times 43. All right, I'm going to run that 3 out. 3 times 2 is 6. 3 times 7 is 21. Now I'm going to see that this is a 4, but it's not actually a 4, it's a 40. So I got to put a 0 in there as a placeholder. And then I'm going to start multiplying that 4 out. 4 times 2 is 8. 4 times 7 is 28. Now I'm going to do some adding. 6, 9, carry the 1. Now we got to get the decimal in the right place. There's in my original problem, there's 2 decimal places, total of 4. So I have to move it 4. 1, 2, 3, 4. My decimal goes right there, and there is my answer. Students mix that up a little bit. They're just not sure where the decimal goes, or they lose track of this guy right here. That's a common misconception. And some students do line up the decimals when you're multiplying. Now you can line them up, you just don't have to. So I'd encourage you not to. 9, 0, 0 times. And decimals there. I just happen to put the decimals in, but you don't have to. All right, so 9 times 4, 6, 3, 9 times 6, plus the 3 is 57. I don't need to do those zeros because they're not going to change anything. But I'm going to go ahead and check the place values. I got a 1 here, 2 here, total of 3 places, 1, 2, 3. Now, it might seem like what you're doing here is you've got, it seems like our problem so far, the decimal always goes at the end, but that's not true. You go over until you don't have any. That's kind of how it works. Let's do this one. Okay, so 5.342 times 13. Let's go to work on this one. 2 times 3 is 6. Okay, 2, carry the 1 times 3 is 9, and a 10. 15, 16. All right. Now this 1 is not actually a 1, it's a 10, so I'm going to put a 0 down as a placeholder. If this 13 was, yeah, anyway, we'll just keep going. 1 times 2 is 2. I got a 4. I got a 3. I got a 5. I'm going to add all these up. 4, 4, 9, 6. And then let's take a look at how many decimal places. Looks like we got 3 decimal places to deal with. So 1, 2, 3. There's my answer. Yay! Let's keep going. Don't stop. Or maybe take a break. Pause it. Go have a snack. And then come back. Welcome back. Yay. Okay, in a division problem, the number you have first is what you have. That's what I have. Why that's important? Because that is what goes in the box. Now we're going to do some long division here. So 17.5 is what's in the box, and I'm dividing into groups of 50. Now notice here that there's no decimal in this, so I can just solve the problem as is. You don't want decimals out here. You can have them in here though. So let's solve, because we don't have them. So I'm going to put my decimal up in my answer, and then I'm going to go ahead and start solving it. So 50 goes into 1 0 times. 50 goes into 17 0 times. 50 goes into 175 3 times. 50 times 3 is 150. I'm going to subtract, and I've got 25 left over. I'm going to tack a 0 in the end because that doesn't change the value of this number when I put zeros in the end. Put a 0 in the end. So 50 goes in 250 5 times. And that zeroes out. The answer is completed. And that is reasonable. If I have $17.50 and I'm dividing it into groups of 50, I'm sharing it with 50 people, everybody gets 35 cents. Very reasonable. Speaking of reasonable, let's talk about this problem. This is what I have. So it has to go inside the box. Sometimes I think about it like a box of cookies. I got to put what I have inside the box. I kind of like cookies. That's why. All right, let's take a look at this one. Now, like I said before, you cannot have decimals outside. You can have them inside, but you can't have them outside, so we need to move it. I'm going to move this one. If we're going to move it outside of the box, we have to move it inside of the box, and then I'm going to put it up in my answer. And now I've dealt with my decimals, and I'm going to now solve my problem because my decimal is in its proper location. 9 goes into 2 0 times. 9 goes into 21 2 times. 9 times 2 is 18. I'm just kind of chipping away at the problem. 3 left. I'm going to drop the 6 down. 9 goes into 36 4 times. Oh, it's done. 2.4. Let's look at this guy. Which one do I have? Do I have the first number or second number? Yeah, you're right. I have the first number. And that is what goes in the box. Got a decimal out here. Alert, alert. Decimal out here. Move it. Move it. Put the decimal in my answer. Nice work on the highlighter there, Mr. Weber. Okay, 9 goes into 1, 0 times. 9 goes into 11, 1 time. So now I can subtract. 11 minus 9 is 2. Drop the 2 down. 9 goes into 22, 2 times, which is 18. 22 minus 18 is 4. I'm going to drop the 4 down. 9 goes into 44, 4 times, which is 36. 44 minus 36 is 8. It's still going, so I'm going to put another 0 on the end and drop it down. 9 goes into 80, 8 times. 9 times 8 is 72. Subtract, I get an 8. Oh, look what we got here. We're going to have a bunch of 80s showing up, so this 8 just keeps going. So my answer actually is 12.48. I'm going to put a little line above the 8 to indicate that it's a repetant, that it keeps repeating itself. A repetant. All right, if you're still doing good, I'm still doing good. Let's keep going. Don't stop. Keep going. All right, this is good stuff. Okay, I'm going to read the question carefully. See, as a gift card, okay, at a superstore, okay, so that's just setting it up. Okay, fine. How many games? I've seen students solve this question, but they didn't actually answer the question. They end up with something else. Ooh, and I get to use estimation. So games are $2.89, so I'm going to estimate it because it says I can. I'm going to say that's about 3. So if games are like $3 a piece, how many 3s are in 20? Let's see. 5 of them is 15. 6 is 18. So it's about 6 games. About 6 games. So about 6. Estimation is super awesome like that. Make sure you use that. If you wanted to solve it like really intensely, you could do the 289, not intensely, but like seriously if you want to do it. Then if you want to find the exact answer, you would do 2.86 times 6. And when you get that all done, you end up with 20.23, which is actually too much. So it really is about 6 games, but it really is 5 games. Next question. Avery decides to buy 1 music album. So that's $10.49. And 1 song. So that's 89 cents. Okay, how much money is left on the card? Okay, so my first step, I can either subtract them both out of the card, but I'm going to add these two together first. $10.49 plus 89 cents. I think that's what I want to do. Yeah, that's what I want to do. I end up with like $11.38. And how much is left on the card? That is going to be a subtraction problem. Lining up the decimals. $20 minus $11.38. And a lot of borrowing on this one. Borrow the 2 becomes a 10. The 10 becomes a 9. The 10 becomes a 9. There we go. That was like a borrow. A lot of borrowing. Okay. $8.62 is left on the card. Yay! Package of 25 pencil costs $5.75. How much does each pencil cost? This one's a unit rate problem. Anytime you bump in a unit rate, you are doing division. So I'm going to build like a little ratio over here. And I want to know how much is each pencil. So I want the pencils on the bottom and money on the top. So $5.75 per 25 pencils. So whatever's on top goes is what I have, and I want to put it in the box. $5.75 divided by 25. Let's go to work. Yeah, we got this. Now, where am I? $25. Okay. Decimal. I'm going to put my decimal in my spot. Just get that all situated. Okay. 25 goes into 5 0 times. 25 goes into 57 twice. Okay. 5 times 2 is 50. 7 left over, right? Drop the 5 down. 25 goes into 75 3 times. The answer is 23 cents. I'm going to stop for a second and go, is that reasonable? Why, yes, it is. How many pencils can you buy for $4.80? You could do a lot of addition, a lot of different things, but what I'm going to do is I'm going to do the division of this one. $4.80 at 23 cents per pencil. Got to move my decimal, because remember, cannot have decimals out here. Clear them out. 23 goes into 4 0 times. 23 goes into 4 0 times. 23 goes into 48 twice, which is 46. 2 2 left. 0, okay. 23 goes into 20 0 times. Put another 0 in. 23 goes into 200 about a lot of times. 2, 4, 6, 8, 10, so maybe 8 or 9 times? Maybe 8 or 9 times? Yeah. So we know it's going to be like right around $20 and like 80 something cents. Yeah, around that. You probably have a better answer than that one. I'm just trying to speed up a little bit. Let's keep going. Okay. So you buy 18 pair of glasses. Oh, taxes. If you're going to find tax, you know you're going to be multiplying them. So $18 times 6%. Now 6% is 0.06. All right. Let's just solve it. Just multiplication. 8 times 6. Carry 4. 8 times 4 plus 1. Got the 10. Check on the decimal places. Looks like there's 2 of them total. 1, 2. So it's 1.08. Is that reasonable? The sales tax is 1.8. The total cost is going to be $18 plus the 108. So my total is $19.08. Now, some people would miss this because they didn't realize that there is another question. And the total cost. So make sure you read the whole question. Okay, party supply store. Okay, $65. I'm going to turn this into a decimal. I'm going to multiply this out. So it ends up being 715 when you're all done with it. And the 2 decimal places is going to be right there. 7.15. So when you work that whole thing out, it's about 715. Oh, and the total cost. So I need to do 65 plus 7.15. For this one, I'm really checking to see, are you keeping track of like place values and lining things up? That's really what we're doing. So 5, 1, 12, 6, about 72.15. About 72.15. I like that. All right. Ms. Miller gets charged $86 to get her hair done. She wants to leave a $15 tip. What is her tip? She should probably leave a bigger tip, like 20%. But I'm going to turn this into the decimal because she's like leaving 15%. That's like old school tipping. Let's see. $86, right? 15%. Okay, I can run this with you. 6 times 5 is 0. Okay. 5 times 8 plus 3, 43. Okay, that's not a 1, that's actually 10. So I'm going to get a... Okay. 1 times 6 is 6. 1 times 8 is 8. Add all this up, and it's like about 1290. Yeah. And let's get the decimal in the right spot. Looks like there's 2 decimal places, so $12.90. Is that reasonable? 10% of 86 is 8.6, because I can just move the decimal over. So 15% should be a little bit more than $8, and it is $12. Yay! Oh my goodness, one more. Yes! All the pages are blank below it, so let's do this one. They are sharing, which is going to be division. So 2, 3, 4, 7, 2 divided by 4 friends. Let's go to work. Get that decimal up on the spot. Okay. 4 goes into 2, 0 times. 4 goes into 23, 5 times. 4 times 5 is 20. Okay. Yes. Drop the 4 down. 4 goes into 34, 8 times. 4 times 8 is 32. Subtract. I got a 2 left over. How exciting. Drop the 7 down. 4 goes into 27 6 times. 4 times 6 is 24. 27 minus 24 is 3. Will it end? 4 goes into 32 8 times. The answer is 5868, but I'm going to make sure, see if it's reasonable. 4 friends. Yes! Did it! Done. Oh my goodness. Hey guys, good luck on your test. Keep practicing whatever misconceptions you have. Google it and look it up, and maybe you'll find a few things that'll even be more helpful than this very video you saw. All right, I'm gonna go chase a panda and see if I can catch it and tickle it. Bye!